Graphing sine and cosine. Okay, so we know that the domain of the sine curve is all real numbers. And we know that the range of the sine curve is -1 to 1. So let me just draw that on here. You can put it wherever you want. Okay, so there are 4 key points on each wave of a sine. There are 4 key points on each wave of a sine. And those are, it goes back to the that circle that I always draw. The 4 key points: 0, pi over 2, pi, 3 pi over 2. That's where the curve is going to hit either its maximum or 0 or its minimum. So the sine of 0 is 0, starts there. And so again, the key points are where the sine reaches its maximum, where it hits the x-axis. Well, technically it's the theta axis. And then where it hits -1. So I'm just going to, freehand, I'm just going to do pi over 2, pi, 3 pi over 2, and 2 pi. Every wave that you graph must have the 4 points, every wave that you graph. So I know that at pi over 2, the sine curve reaches its max. At pi, it hits the x-axis. Technically, it's the theta axis. And then at 3 pi over 2, we hit -1. And at 2 pi, we hit the theta axis again. And with my handy dandy erasable pen, in case I really royally mess this up, which has been known to happen, that is one wave of a sine curve. The period is 2 pi. The period will also be known as t. Period, also known as t, is 2 pi. And the amplitude is the half of the height. The height of this graph is from 1 to -1. And the amplitude is half of that. And then our domain is all real numbers. And our range is between -1 and 1. Also known as -1, 1. There is your sine curve. Cosine looks very similar. Cosine looks very similar. Oh, so this is the whole thing. 4 points, 4 key points, technically 5, right? 1, 2, 3, 4, 5. And then after this, it would just keep going and going. And in the negative direction as well, it would keep going and going. Cosine and sine are just shifts of each other. Cosine and sine are just shifts. So let's go ahead and do the same thing. I drew a really large grid. Hopefully you are doing this along with me. So the cosine hits its maximum when theta is 0. When theta is 0, cosine hits its max. Pi over 2, the cosine is 0. At pi, the cosine is -1. 3 pi over 2, the cosine is 0. And 2 pi, the cosine hits its maximum again. And, all right, I'm going to go for it. I'm going to regret this. Not bad. Not bad. So the period, again, known as t, that's just the variable that is used. Amplitude is 1. You can abbreviate amp. The domain is all real numbers, and the range is -1 to 1. They have exactly the same information. Period 2 pi, amplitude 1, domain all reals, range -1 to 1, 4 key points. So that is your parent function for sine and cosine. So notice that the sine curve, so if this is cosine right here, the sine curve is a shift right pi over 2. The sine curve is a shift right of the cosine curve. Sine curve is, the sine curve is a shift right of the cosine curve. Just helpful to know. Let's look at some shifts. I think the amplitude shifts aren't so bad. I think you know how to move things up and down. We're going to talk in this video about changing the period, not necessarily shifting right and left, just changing the period. So let's say you have something like y equals 3 times the sine of, how about 4? Your book uses x. So I'll just start getting used to using x. Your book, when you graph, they use y and x, but when they are evaluating, they use theta. So I don't know. All right, something new, and this is notation. Y equals A, amplitude, the sine of, you used to call it B, but now we call it omega x. We don't use B anymore, we use omega. Okay, why is omega important? It determines the period. Omega determines the period. So the period, which previously I told you was t, is equal to 2 pi over omega. What? What essentially omega does is it tells you how many cycles, how many waves do I have, up, down, up, down, up, down. How many waves do I have between 0 and 2 pi? So in this problem, omega is 4. This means that there are 4 waves between 0 and 2 pi. Omega tells you the number of waves. The number of cycles, the number of waves, I'll use them interchangeably. So since this particular graph has 4 waves, that means from 0 to 2 pi, I have to squeeze in 4 waves. Clearly not that look like that. So if I have to squeeze in 4 waves, each one of these waves has to be a lot closer together. Their wavelength, their period can't be 2 pi. Well, what does their wavelength need to be? The wavelength, period, wavelength, same thing. For this particular problem, the amplitude A is going to be 3, but the period is going to be 2 pi over 4, which is pi over 2. A, amplitude, the coefficient on sine cosine. A is the coefficient on sine cosine, also known as the amplitude. Okay, so this graph is going to have for 16 increments. We're not going to draw the whole thing. But I am going to at least show you how to do most of it. Okay, 3. I'm not concerned at all that you're counting increments. How about, let's put 3 here. Great, good enough. Like, I don't really care where you put them. Just make sure that they're equidistant from the axis. Okay, so each wave is pi over 2. I'm gonna do this for sure in an erasable pen. Great. Pi over 2. I'm glad I used erasable pen. Let's move it further down. Let's say this is pi over 2. That means that one wave, it's gonna go up, it's gonna come down, and it's gonna go back up, and that's pi over 2. Well, guess what? There are 4 key increments. I wanna know at what angle does it reach its high point? 3. At what angle does it reach the x-axis? 0. Theta axis. At what point does it reach its minimum? -3. And then I know that it comes back and hits the its x-intercept, sorry, theta intercept is at pi over 2. Well, and then I got to keep going again. And that wave has 4 increments. And the next wave has 4 increments. And the next wave has 4 increments. So do you have to draw all 4 waves? No. How do you know? You'll read the directions and I'll tell you graph 2 cycles or graph from 0 to 2 pi or whatever. So for this one, we're not going to graph to 2 pi because it's just cumbersome. So if the period is pi over 2, this is always the question I get. 0 to pi over 2, and I have to slice that into 4 sections. Why 4 sections? Because there are 4 quadrants in the unit circle. I'm splitting it up, 1, 2, 3, 4. So if I'm splitting this up, pi over 2, splitting that into fourths, this means that my increments are going to be pi over 8. Okay, so that means that, hold on a second, 2, 4, yeah. The first increment is pi over 8. If you struggle with fractions, this is going to be like really difficult for you. Each increment is an eighth. So the next increment is going to be 2 pi over 8, which is pi over 4. And the next increment is going to be 3 pi over 8. And the next increment is going to be 4 pi over 8, which is pi over 2. Let's keep going. Let's just do one more cycle. What am I doing here, 2's? So 4 pi over 8, 5 pi over 8. The next increment is going to be 6 pi over 8, 3 pi over 4. The next increment is going to be 7 pi over 8. The next increment is going to be 8 pi over 8. We could keep going, but 1, I don't have enough paper, and 2, we've got other things that we need to do besides graph, 4 waves in increments of 8. All right, so I'm going to graph this. High point, intercept, low point, intercept, high point, intercept, low point, intercept. All right, so this right here represents 2 cycles, 2 waves. Notice that 2 cycles, 1, 2, was from 0 to pi, which means that from 0 to 2 pi, there would be 4 waves. From 0 to 2 pi, or yeah, from 0 to 2 pi, there would be 4 waves. Let's do a vertical shift and a reflection. We're not going to do any right-left shifts right now. So let's look at, let's do y equals -3 cosine pi over 4 x plus 2. Okay, so just like when you are shifting a log graph or when you are shifting, an absolute value graph or whatever, the +2, this is your vertical shift. Now, be careful. The amplitude is not -3. Amplitude is always greater than 0. You can't have negative height. So this means that the amplitude is 3 with an x-axis reflection. Theta axis, I'm going to screw that up all the time. I'm going to say x. It's technically theta. All right, there I said it. Amplitude is not negative. If you tell me the amplitude is negative, you're going to lose points. Amplitude is a height. All right, amplitude is a height. So this is, amplitude is 3, x-axis reflection, and this is up 2. All right, let's figure out our period. Pi over 4, so this is strange. Omega is pi over 4. This is weird. So if you remember, I said in the previous one that omega tells you how many cycles. So this means that there are pi over 4 cycles, waves, whatever, from 0 to 2 pi. What is up with that? Pi over 4, so pi is 3 point blah blah over 4, like there are 0.7 cycles? What the heck is that? We'll take a look. The period, I'm going to use t and omega a lot until you get used to it. So t is 2 pi over 4, which I believe is 8. Okay, so that means that my intervals are going to be 2. All right, so what is this, a cosine curve? Whatever. It goes from where it starts to where it ends is 8. So cut that in fourths. 2, 4, 6, 8. There's no pi. Pi has reduced out. There is no pi. It is 2, 4, 6, 8. Okay, great. But what about this up to? So there are certain words that I love in mathematics, and this is going to be one of them. What am I doing? I'm doing up to. So if it's up to, I'm going to put this down a little bit further. An amplitude of. Okay. So I've shifted it up to. So if I'm going to do 2s, let's say that I just do, let's go by 1s. So this is 2. All right. You need to draw this next part in, and is called the sinusoidal axis. It's one of my favorite math words. You end up with cosine theta, equals 2, and that is called the sinusoidal axis. Even though it's a cosine curve, it doesn't matter. It's not the cosinusoidal axis, although that would be pretty fun, but it's not. It's called the sinusoidal axis. Whatever the vertical shift is, so this up to, that's automatically your sinusoidal axis. It needs to be drawn in. Don't be lazy and then just all of a sudden make that your new theta axis, because it's not. All right, so from here, my amplitude is 3. From here, so I've just taken this axis and I've shifted it up. So up 3, down 3. 1, 2, so that would be 5 and -1. From the x-axis, I went up 3, sinusoidal, and from 2, I went down 3. And now I have my wavelength is 8. My increments are 2. 2, 1, 2, 3. And you can put, as long as they're spaced out equally, no problem. Like, I don't care if you have them, you know, each increment is 2, or if you spread it out and do every 5 is 2, it doesn't matter. And then plot your points. Not super pretty, but don't forget it's reflected. The -3, it's reflected. So I started at the minimum, and the minimum is now at -1 as opposed to being at -3. It was at -3, and then whoosh, the whole thing got shifted up 2. That is a reflected cosine curve with a period of 8. Okay, let's work backwards. So I will pause the video here, give you an opportunity to copy down the graph. Let me zoom in for you. Okay, and we're going to work backwards, writing an equation given a graph. There are 4 possibilities for every given curve. 4 possibilities. You could write as a positive sine curve, a reflected sine curve. You can write it as a positive cosine curve, or you can write it as a reflected cosine curve. How do you know which one's best? Okay, I always go based off of the y-intercept. Because if I can write the curve based off the y-intercept, I don't have to worry about any phase shifts. I don't have to worry about any phase shifts. So the y-intercept for this particular curve is at the minimum. It's at the minimum. So which curve starts at the minimum? Does positive sine curve start down here? No. Positive sine curve starts at the origin. Does negative sine, or does a reflected sine curve start at the minimum? No. A reflected sine curve also starts at the origin. It just goes down instead of up. Does the positive cosine curve start at the minimum? No. A positive cosine curve starts at the maximum. So if I start at -5/2, this is going to be a reflected cosine curve, meaning it's reflected, A will be negative. Not my amplitude, but A. So what is the amplitude? Well, half of the low to the high. So I think you can see that the amplitude is 5/2. The amplitude is 5/2, but A will be negative. So this is going to be -5/2 cosine of something. Now what matters is the period. Every wave, regardless if it's a sine, cosine, reflected sine, reflected cosine, all have the same length. If I say, okay, I'm going to start it, let's just say I start it here at -1. And I'm going to go down and up, and that ends at +1. So if I started at -1 and I went down, up, I ended at +1, that would be a wavelength of 2. Okay, let's say you started at -1/2 and you went down, so you started at -1/2 and you followed the curve and you went down, and here's where the cycle ends. From -1/2 to +3/2 is 2. If I start at -5/2 and I go up, down, it is assumed that each one of these increments, it's not assumed, it's given that each increment is a half, 1, 2. So this would be 2. So even though it wasn't drawn, based on the fact that there are arrows from from 0 to 2, the wavelength, the cycle, the period is 2. So I need to work backwards to find omega. So T, which is the period, is 2 pi over omega. I'm not very good at drawing that letter. So I know the period is 2. I'm working backwards. So when you solve for omega, I believe you get pi. Yeah. Omega is pi, right? 2 omega divided by 2. Yeah. So my final equation is pi x. Which one should you use? First of all, if I don't tell you, you can use whichever one you want, but I would definitely start with the y-intercept and go from there. And that is an introduction to graphing sines and cosines.